Hello guys, so welcome to this new video, and in this video we are going to learn how we can create a session and use a session for executing a transaction. And this transaction is basically a transaction in which we are going to increment account. So we have a function in a contract that I wrote, and it's a normal contract and it has a normal function which is incrementing the count. But before all of that, we need to learn that how we can create a smart account, and I'll teach you how you can create a smart account using EOA, which is we'll take the signer from the MetaMask account that I have, and using that we'll create a smart account for ourselves, right? So let's just get into the code and learn all of these things together. Let's get started, guys. All right, so as you can see, we have like I have already set up this Biconomy Session Key demo, where you can see we have two options: Ethereum, Sequoia, Polygon, MOI, and you can just connect to any chain and then do a EOA sign in, right? Right now we haven't written the connect function yet, so we'll have to write that first. So let's just get into the code and see how we can do that. So first of all, we have to define Ethereum. Should be like this, and then we can just go and create a provider, or we should start with a try block and add a catch. Like that, and now we will define a provider which should be new ethers.provider and Ethereum, and then we will await and send a request to bring the accounts, and from that we can grab the signer like this. Okay, so now we are going to pass this signer into the smart account object that I'm gonna write, and using that signer we are going to generate a smart account for ourselves, right? So let's just go and see how we can do that. But before, we should be having a config file so that we can grab anything from it. So like the Biconomy paymaster API key, which is chain selected. Now you must be wondering what is chains and chain selected. So I have already defined chains. So we have Ethereum, Sequoia, and Polygon MOI, and all of the details about it, like provider URL, increment, contract, count, address, right? So, and other essential details also. So we will just grab it from there. And for that, now what we need is a bundler URL, and a bundler URL will look like this. Then we'll need what else do we need? I think I think that should be good to go. For testnet bundler URL, you can get it from the dashboard. For mainnet bundler URL, you will have to contact us and we'll provide you with one. Next, what we have to do is we sometimes face while executing a transaction, we sometimes fail exceeded maximum duration, and we don't get the user of receipt or a transaction hash. So to avoid that problem, we'll separately create a bundler instance where we will define the times intervals, and it should be done like this while creating a bundler. And in this, what we have to pass is first the bundler URL, which we can get from here, right? Config.bundler URL and user op. So this is what is important. Okay, so this is called user op receipt max duration intervals, right? And we have to define this. Now what is this? Basically we are checking, so this is the maximum time for which we have to check whether we are getting the user of receipt from the bundler, and this is how we define the maximum duration for it. So it should be done like this. You have to write your chain ID here, and the chain ID should be like this. Yeah, like this, and the timing should be 2 minutes, which should be 120,000 millisecond, right? So 120,000 millisecond is equivalent to 2 minutes. And same thing we can do for user of receipt intervals, and we can just do it like that, similar to, but user of receipt intervals is after how much interval we should check for the user of receipt. Okay, so for that we can just assign it to 3000 millisecond, which is 3 seconds exactly. Okay, so this is how you create the bundler instance, and we'll have to pass this bundler instance into the smart account, like create smart account client object, and we'll see how we do it. So now what we need is a smart wallet equals to a wait create smart account client like that, and in this what we need to pass is the signer first. Okay, the signer should be the signer that we grabbed earlier, and a Biconomy paymaster API key, which should be the config dot Biconomy paymaster API key, and a bundler instance like that, and RPC URL is also required. So that would be the chain selected provider.url, which I have already defined, and then we need chain ID. So basically these are the important things that you need to pass while creating a smart account, and make sure that all these information are correctly passed, and or you'll face an error. So yeah, we'll get a smart wallet, and we'll just set that smart wallet to the smart account like this, and also we'll get the smart account address. So the smart account address should be away.smartwallet.get address, and we'll set that to smart account address like this. All right, so that's all we got to do, and now what we have to do is go on to the local host and then try out that whether we can create the smart account or not. So we'll just go into the local host like this. Yep. So now you can see this is the Biconomy Session Key demo, and you can see we have two chain options, which is Ethereum Sepolia and Polygon MOI, and we are doing this on Polygon MOI. So EOA sign in and basically taking the signer from my MetaMask account and creating a smart account. So we'll just go and hit on EOA sign in and see if we can get C. So oh my god, wow, it's great that we have got a smart account address, and now you can see we have two buttons here. The network is Polygon MOI. Two buttons are create session and increment count. So create session is the button where we are going to create the session, and increment count will be the execution of the transaction, which is basically using the session. And get count value, you can see get count value is nothing but getting a count value, and since I told you about the increment count function, which I already wrote, which basically increments the count. Yeah, so now we have got to go and write the code for creating the session, and let's hit the code again and create the session.
Let's go.
Alright guys, so now we are going to learn how we are going to create a session for the transaction, which is increment count that I told you about. So let's just go, and so I have already a function declared which is called create session with sponsorship. Okay, so here we'll just write the code for creating the session. But before that, I think we should declare a very important thing, which is with sponsorship, and which is nothing but just showing you that we are declaring sponsorship mode, which is going to be used in somewhere in the code. Okay, so it should not be like this. It should just be a simple object with paymaster service data. Paymaster service. Wait. Service data, and this should be the mode, which should be the paymaster sponsored paymaster mode. Paymaster mode dot sponsored, this one, right? So this should be the with sponsorship, and now we're gonna write the code for it. So the very first thing is that we need to create a key store. Okay, so for creating the key store, what we have to do is we'll call a function which is called create session key EOA. Okay, so for that we just have to take session key address, which will be exported from that particular function. Then we have session storage client. So these are the two important things that we have to take from the function. So await, create session key EOA. You can see this function right now. Let's see what this function needs. Okay, so if you hover over this, you'll see that it looks for 2 or 3 arguments, which is smart account and chain, and session storage client. I think that is not necessary, so we're just gonna write smart account instance. So we have already the smart account instance and the chain ID, which will be chain selected dot chain ID. Okay, we're seeing an error here. What is this? All right, so this is a type error, so we can just ignore the type error by doing this. Okay, so just like that, it's done. And now what we are going to do is we are going to define some rules. Okay, so let me tell you about rules. Okay guys, so rules are necessary when you are doing a contract function which needs some arguments. Okay, so let's say if you have a function which needs arguments, then you need to define rules. Okay, but if you don't have that, like that contract function doesn't have any kind of argument, so you don't need to pass the rules. You can just pass the rules as an empty array. So for this function we don't actually have any argument in increment count, but I'm still gonna tell you what rules are and how you can do. So let's just write const rules, and should be like this, an empty array. And now see, we have a field called offset. So offset is, for the very first argument it should be 0. For the second argument it is basically a 32 word byte, so 32 multiplier. So when you are going to write for the second argument, what you have to do is write offset as 32. Okay, so and the second thing that we have is condition. What is condition? So there are multiple numbers for conditions. So 0 means equal. Okay, 0 means equal, 1 means less than or equal, then 2 means less than, 3 is greater than or equal, 4 is greater than, and 5 is not equal. So these are some of the conditions. Now what are conditions basically? So let's say if you have an argument called smart account address. Okay, so now let's say you are taking the first argument as an address. Okay, so you are passing an address into that argument. So the offset is basically 0 because it is the first argument, and the condition is that you are checking in the contract function that whether this address is equal to some address. So you should be passing that the condition that you're checking in that function is equalness. Okay, so the condition should be 0 for that. And there is also called a reference value, so which you're comparing against. So you're comparing against the smart account address itself, right? So this is how it works basically. So you don't need to pass rules for this particular function because we don't have any arguments, but this is how it works. Now if you have to write the second rule, which is for the second argument, then just create another like this. Again, offset should be 32 here, and then the condition accordingly. Okay, so we can just pass it as an empty array, just like that. Okay, or we just don't need to write, we'll just write rules as an empty array. Okay, cool. And that's it about rules. And now we should head and get to know about policy. Okay, so const policy, which is, whose type is policy. Wait, it's an array. So it's an array of objects. So in this we have to pass the session key address that we just got from the create session key EOA. So we'll just pass it like that. Okay, And then we'll have to pass the contract address. So the contract address is the increment count contract address. So I'll just write contract address, and it will be the increment count contract address. And then we have the function selector. Now the function selector should similarly okay, it should look like this: increment count, like that. Okay. And if you have something like maybe an argument here, so you just have to pass an address. Okay, maybe UN256 if you're taking the second argument also. So for this function we don't have any argument, so we'll just leave it like that. All right. And then we have okay, yeah, the function selector is increment count. I think it's increment. Yeah, the function is called increment. Yeah. So right now there is rules, which is an empty array that we're gonna pass. Cool. And then we have interval. So this is important, guys. So your session needs to have an interval, or you can just leave it like that. Maybe you can just not set any interval and you want your session to be alive for almost all the time. Okay, so you can also do that, but for that you need to have valid until, which I'm setting as 0 because I want the session to be live as long as it can. Okay. And then we have value limit. So value limit is nothing but the maximum value you can send in a single transaction, which here again I'm not sending any kind of value, so it should be 0, right? I'm getting this error.
Don't you dare.
It's again a type error. Dude, I literally hate sometimes type error, but wait, I've got a solution for it. Cool. So that's all about policy, and yeah, this is how rules and policies are defined. Okay, cool. So now we have rules and policy already defined. So what we have to do is now create the session. So for that we'll have to create the session like this. We'll take wait and session from it, and await like create session, and let's see what create session takes. So create session takes around 2 or 4 arguments, which is smart account, session key address, policy, session storage client, and this is the with sponsorship, which we already have written. Okay, so what we are going to do is, I think the first argument that we have to pass is the smart account instance, and then the policy, the session storage client, and the last thing is the with sponsorship thing. Okay, again the type error. All right, never mind. Okay, cool. So that's how we create a session, and now we can just use this wait to await it, right? And get the transaction hash. So we can just simply write like this: seat transaction hash, and we can also take a success. Success is nothing but a boolean, and yeah, so we have both of them, and then we'll just, let's say, console log it. Console.log success and transaction hash. So if it's true, we're gonna get the transaction hash, right? So this is literally how you create a session. Okay, so for this increment count function, I have created a session which kind of look like this, and we'll be able to create a session, I hope so. But yeah, we'll be able to create a session, and you can just look into this code. But now the most important part is that we have to use this session. Okay, so our session is valid until, like, it is valid until an unlimited of time. So you don't have to care about the timing of it. You can literally use it any time you want. You just need the session to be valid. So session has already been created and you can use it. So now we're gonna use this session, and I'll show you how you can use a session. Cool. So now we are going to see how we can use the session that we just created. So we haven't created the session yet, but we have written the code for it, by the way. So yeah, let's see how we can like use the session. So yeah, just increment count will be the function. Okay, and we'll just go. And the first thing that we have to do is create a emulated user smart account. Now, what is emulated user smart account? It is nothing but a smart account instance of the session smart account that we're gonna use. Okay, so normally we'll write like emulated emulated users smart account. Okay, and it should be await create session smart account client, exactly. And yeah, it should be like this. Okay, now let's see what it looks for. So primarily it looks for 3 arguments, which is Biconomy smart account config, which is a smart account instance, and we have conditional session and session type. Okay, so we'll just enter the account address for now. Okay, and that will be the smart account address. So account address is the smart account address, and we have the bundler URL which we are going to pass, and that will be this thing. We have paymaster URL, which will be again this thing, and then chain ID. Yep. And then after this, as we saw, we also need to pass a smart account address. Okay, so what it actually says is that, so the smart account address is nothing but you have to pass the smart account address if you're using a default storage for your environment. Okay, so and other than that, this is the smart account config, and this is again a type error. Yeah, so this is the emulated user's smart account, and now we are going to write a transaction object for the increment count transaction that we have. Okay, so for that we just have to write mint transaction, which should be 2 is the contract address, so which looks like this. Wait. Chain selected dot increment contract address, right? And then we have the data, which we are going to pass the encode function data, right? And this will pass the ABI, which will be the contract ABI, and then we'll have the function name, which will increment and arguments as an empty array, because we don't really have argument. Okay, so yeah, so this is how our transaction object looks like. Cool. So after this, what we have to declare is the params which we are going to send while sending the transaction. So okay, so what is params? I'll tell you about params, but before that I'll just write the function like this, get single transaction params, exactly. And let's see what it requires. So it requires basically the corresponding index, conditional session, and a chain, right? So smart account address will have to pass, and the chain ID. No, we have to pass the chain, right? Let me see again. Yeah, we'll have to pass the chain. Cool. So this will be the chain, and this will be the index, which is index of the relevant policy leaf. Okay, so let me just tell you what I've done here. So basically these are params. So when you need to pass a single session, okay, so let's say you have created multiple sessions for multiple transactions, okay, different sessions. So if you want to execute a particular session, so particular params for that, okay, so this is how you do, right? And that's how you execute a transaction. So this is why we need params. Okay, so guys, just while creating the session, I forgot this should be the chain and not the chain ID. Okay, and create session key AOA, it actually looks for a chain, as you can see, right? So it should be chain and not the chain ID. But now since we have the params, we are all set for sending the transaction. So let's just go and const wait. Let's do a wait and emulated user smart account or send transaction. So emulated user smart account is the smart account instance of the session smart account, and this will be used to uh, send the transaction. So we'll see for sending the transaction what we need, and we need primarily the mint transaction, and then the params. Wait, what was this? Okay, and then we need the with sponsorship. Shoot. Cool, it looks all fine now. And then what we have to do is so since we are doing wait, and we also need it to wait, so receipt, we will get the transaction hash. Transaction hash like that, and success. Just wait, right, just like that. And we'll set this transaction hash because I wanted to show you guys how the transaction hash looks in the Explorer. Okay, yeah, cool. And after setting that, I think we are done with using the session. So yeah, this is how you write the code for using the session, and this will be executed, and this should be executed only after creating the session. So once you create the session, you can call this increment count, and you're good to go. The count will be incremented. So yeah, that's it for the code. I'll just add some toastify. So I'll just add some toastify so that the execution looks more nicer. So just give me a second and I'll add that magic effect.
A few moments later.
Cool, done and dusted. Now we have put the toastify and it looks good. Let's see how it looks. Again, I'm gonna brief you. What we're going to do is creating the session and then using that session. So we'll just go at the window and let's sign in again. So we'll just go and do a sign in, and now you can see, let's see the count value first. So it should be 124. Okay, so it's 124. Let's create a session now. So I'll just hit create session, and now you're gonna see a MetaMask pop-up, which is basically for signing the transaction, and so that it will just create a session on behalf of us. And we'll just wait for the session to be created. It'll just take a while. Now you can see session creation successful. Okay, so the session has been created, and now what we can do is increment count. So when I hit on increment count, we'll just wait for the count to be incremented. It will again take a few seconds, and session creation is successful, and you can see the transaction hash here. And let's see whether the count has been incremented or not. And if you see, it's 125 now. So it has been incremented by 1 by doing the session creation and using it. We can also see the transaction hash on the Polygon MOI explorer.oklink.com, and you can see all the details here, right? So this is what it is, basically session keys, and you can use session keys for doing not one but multiple transactions. Okay, and session keys are good for improvement in the user experience, as you can literally you don't have to see any MetaMask pop up anymore, and you can just bunch all the transactions in one session, and on the behalf of the user you can execute the session even if the user is not present. Okay, so the user have to sign that session only once, and then you can use that session as a dApp developer. You can use the session for executing the transaction, right? So that's it for this particular video. I know it was a lengthy video, but you have learned a lot in this video, how you can create session key now and how you can use it. So just go into the description box, check out this cool dApp demo of session key that I created for you guys, and also the repo. You can just play around with things, try out something better, and let me know in the comments what you tried with session keys. And it was really nice telling you guys about session keys, and thank you for watching this video. I see you in the next video. Thank you so much.